We have come to midpoint theorem, and midpoint theorem states that given that B and C are the midpoints of AD and AE respectively, we can see two results. Number one is that BC will always be parallel to DE, or in vector definition, vector BC will always be parallel to vector DE. And number two is that BC is always half of DE, or in other words, vector BC is equals to half of vector DE. And do take note that out of the four statements, this statement will be the most powerful because this statement will give us two results. One is that it tells me that BC is parallel to DE, and number two is that BC is half of DE. So now we come to one question, and before we start, I want you to read the question very, very carefully and understand what it's asking. So this diagram shows PQRS is a quadrilateral and that A, B, C, and D are midpoints of the following lines. First question is to show that PR is parallel to AB and PR equals to 2AB. So this suggests that we can use midpoint theorem, but I can't just write two words, midpoint and theorem. I really need to prove it and write down the steps. So first I'll write down what I need is that I'm looking at AB as the key midpoints of QP and QR. Let's write down this first statement is that AB equals to QB minus QA where my pit stop is at Q. I'll write down the same for PR and PR equals to QR minus QP where Q is the pit stop again. And let's think if you're able to continue to show my results that I want. And I realize, hey, QR equals to 2QB since B is the midpoint of QR and QP is 2 times of QA because A is the midpoint of QP. So factorizing out common factor 2, I'll get this. And now I know what is QB minus QA, which is simply my AB. So since PR equals to 2AB, I can have two results. Are you able to write the two results of this very powerful statement? Number one is that PR is parallel to AB, which is what I want to show, because this is in line with parallel vectors that we have learned. And secondly, I can also write that the magnitude of PR is 2 times of the magnitude of AB, which will give me that the length PR equals to 2AB. So these are the two results that I want to show, and this part question is done. Now we'll bring our attention to part 2, where we want to show that ABCD is a parallelogram. And interestingly, the requirement for parallelogram is not two pairs of parallel opposite sides. Because as long as I can show that there's one pair of equal and parallel opposite sides, like this, then I have no choice but to prove that when I join all these four vertices together, this shape will definitely be a parallelogram. You can try it out for yourself on a piece of paper. So basically, I want to show that AB equals to DC and AB is parallel to DC. So let's try to show this and think about how we should start this question. Since C and D are midpoints of SR and SP, I can write down two results. Number one, PR is parallel to DC, and number two, PR is 2 times of DC. So I've actually used my part 1 answer to get this same result. So number one, because PR is parallel to AB from part 1 and PR is parallel to DC, I can actually prove that AB is parallel to DC, which is what I want to show here. So let's do the same for result number 2. Since PR equals to 2AB from part 1 and PR equals to 2DC from what I just showed, then I can show that 2AB equals to 2DC, which will also which will eventually give me AB equals to DC. And that is result number 2, which is what I want to show. So hence, I can show that ABCD has one pair of equal and parallel opposite sides, AB and CD. Thus, ABCD is proven to be a parallelogram.